Quadratic functions are everywhere, in physics, business, engineering, and even the games you play. But most people only see equations instead of the code hidden inside them. Today I'm going to show you something different. In this subject, you'll see three strategic lenses: the standard form, the vertex form, and the factored form. Each one is to look like a different camera angle on the same parabola, revealing its secret instantly: the y-intercept, the peak value, the roots. By the end of this lesson, you won't just solve the quadratics. You'll read them. You'll understand how to predict maximum revenue, pinpoint a project's peak height, and optimize geometric shapes, just like the real-world example shown in this module. So if you ever wanted to math to finally make sense, stay right here. Let's unlock the parabolas code. So I'm gonna the first way that we can convert one standard form to the vertex form. But what would happen if I do have the a and my a is not going to be equal to 1? So I do have some problem on that time, right? At that point, we do have another kind of a step, which somehow is like the previous one, but it's just a little bit of advancing part that you have to be careful about. How does that works? Let's just talk about it. Again, at that point, we are going to start step 1. Step 1 would start with factoring of a out of the first two terms. It means that I do have ax squared plus bx plus c. So the very first way, rather than just isolating these two values, is that I have to factor the a. So it would be ax2 plus b divided by a times x plus c. So it means that by factoring, I'm not changing anything, because a times x is a squared, a times b over is still bx, so I'm not changing anything, right? That's the factoring. After that one, I have to find the inner piece. How I can find the inner piece? Inside the parentheses, take half of the new x coefficients. What is my new x coefficients? Is b over an a. It's not b anymore, it's b over a. So I have to square that one. After square that one, again we do the balancing one, adding and subtracting, and after that factor and simplicity. The only thing that we added over here is the factoring of a, and also by adding and subtracting, we have to be careful about another thing that I will show you inside the example itself. So imagine that I do have this example: 2x2 plus 8x plus 3, and right now I'm trying to find the vertex form, or in another way of thinking, I'm trying to find the minimum value, because a is bigger than 1, so probably would be like this, and I'm looking for this one. Since a is bigger than 1, I have to use the seconds, just the second form, right? So the very first thing is that I have to isolate the x and also factor my a. So it would be something like this. It means that 2 times x2 is still going to 2x2, 2 times 4x is going to be 8x. After that, I have to consider my new b over a, or I have to consider my new b. My new b, which I can call as a new b prime, is going to be 4, right? So I need to find the half of that, and I have to square it. So if I do that one, it means that my new b over a was 4, and I just did is I just squared it. So for the third step, I do have something like this one. So at this point, I do have my 2 times x to the power 2, which I already have, plus 4, which was the square root of b over a. Again, guys, remember, at this point, my new b was 4. But right now, the question asks to square the b over 2a. It means that I have to half that guy, like the previous form, and after that, find the square of that. So at this point, I do have 4, and I have to be careful, because if I would like to keep the balance, I have to subtract it by 8. Why 8? Because if you just do this kind of simplification and get rid of parentheses, you have 2x2 plus 8x plus 8 subtracted. Imagine that we forgot to subtract it by 8 and we subtracted by 4. So if we do that, actually we are going to lose the balance, because 2x2 plus 8x, yes, this is going to be the first part, but this part is going to be 8 minus 4 plus 3. It means that 5 plus 3 is 8. We are not going to have the balance that previously we had. So be very careful. Whatever a or coefficient that you have, you also have to consider it for the subtraction. So far, I had x to the power 2 plus 4x plus 4, and this guy is going to give me a perfect square or some kind of a perfect form that we call it as x plus 2 to the power 2. Again, if you want to find out why that works, just multiply x plus 2 by itself 2 times and you completely understand what is happening. Again, don't worry, I'm going to make a new some kind of subject that is going to talk about it with lots of examples, so I'm making sure that you guys completely understand it. So far I do have something like this, and I do have that one. Again, I do have this guy. So again, simple, right? So at this point, my h, remember, is going to be -2, and my k is going to be what? Is going to be the 5 itself. Did I do something wrong? No, probably right. I'm sorry, the k is going to be -5. Again, look at this formula. X minus h, which I do have it like this one, -2 and -5. Let's just prove it that actually works or not. So at this point, I need to find a -b over 2a, right? -8 divided by 4 is going to be -2, and this is going to be my h itself, and probably if you put that one inside your equation, you're going to have the -5 itself. So that was about finding the vertex form out of the standard form. Let's talk about how actually we can find roots, and by finding roots we can find the third form, which is going to be actually the thing we are looking for, because the important part about each function or some kind of quadratic function is about the roots. Actually, we are going to solve that one. So without further ado, let's just talk about this. So let's talk about it. The universal solver, and it's a crystal ball. What does that mean? It means that if you have a standard form of your quadratic equation, x to the power 2 plus bx plus c is equals to 0, and if you would like to find those roots like the way that we have for the previous part, we do have a formula for that. And x, which is going to be for my roots, x1 and x2 equals -b plus minus square root of b2 subtracted by 4ac divided by 2a. What is plus and minus? X1 is going to have plus and x2 is going to have minus itself. By this way, we are going to see that what would happen to the roots of my standard form itself. So b2 subtracted by 4ac is sometimes considered as the crystal, sometimes going to be as discriminants, is the way that we are going to use in order to find those roots. So the workflow is like this. Identify a and b and c in your work. Calculate this delta, or some kind of we call it as discriminant delta, and plug the values into the formula in order to find the exact roots. For instance, I do have 2x2 subtracted by 4x plus 1 equals to 0, and I would like to find my roots. Instead of just using all of previous ways, I can use this one, and after that use it inside the formula that I had in order to convert it to the second formula, into the third one, if you remember. So a is 2, b is -4, and c is 1. So delta is going to be like this, and after that 8 is going to be my delta. Put the value over here, and your roots are going to be 1 plus root 2 divided by 2, and 1 subtracted by root 2 divided by 2 itself. So here's the idea. At some points you would say that, okay, is there any way for us in order to understand that actually how many roots do we have? Because you mentioned that we are going to have 3 conditions, right? So, and I would say that yes, the delta is special. That delta, or the number beside the some kind of square root, is going to give us some information about the whole idea. Rather than just knowing the fact is going to be opens up or opens down, we can understand that how many times actually our some kind of function is going to have intersection with x-axis. Is it going to be either 2, 1, and 0? If I do have a condition, my delta is bigger than 0, b2 or b to the power 2 subtracted by 4ac is bigger than 0, I do have the first condition. What is the first condition? I do have 2 roots, and those 2 roots are going to be different. If I do have a condition that b2 subtracted by 4ac is equals to 0, I do have a condition that I do have a root, and actually there are 2 roots, but since those 2 roots are the same, or those 2 roots are going to be minimum or maximum of my function, I'm going to say that I only have 1 root. And the last one is a condition that my delta is going to be smaller than 0, and at that point I don't have any roots. So it would be a little bit controversial for some of you that know about the complex numbers, because you know that right now, based on our current knowledge, we don't have any answer for the root of negative numbers. But at some points, we can define some kind of unrealistic numbers or imaginary numbers that we call as a complex one, and again we can find some numbers that actually doesn't exist, but we can define them. So right now we don't consider them. The only thing that you need to know is that when the delta is smaller than 0, there are no roots for your equation itself. So as you can see, if delta is bigger than 0, the first condition, delta is equal to 0, the second condition, and delta is smaller than 0, the third condition itself. So we talked about different kind of ways of how we can convert the standard form to the vertex one and to some kind of another form. And so why we do need that? Because not only we have to understand everything about the quadratic equation, but also we have to apply it in the real world, right? That's the way it works. That's the way math or any other kind of science works. I have to use it inside something to make sure that actually that's applicable. So let's see three kind of different situations that why we would like to convert the standard form to another one, and you guys can completely understand what is the actual benefit of knowing this subject. So imagine I do have a strategic question. A businessman comes to you and wants to know a thing. A business wants to find the optimal price to achieve maximum revenue. What are we looking for? It's the maximum point. Which lens is the best is the vertex form. Why the vertex point? Because if you guys remember, the vertex point is going to give me that specific point that's either is going to be maximum or minimum, right? So let's talk about it. Let's try to quantify anything. So the very first thing that we have to know is a scenario. So imagine that store sales is going to follow a model. Let X be the number, the sales, and actually the number of $5 price increases. Let's imagine that X is going to be a number of $5 price increases, and price is going to be something like this. 5X is going to increase $5, $5. Imagine that scenario. Okay, you can consider other scenario, but let's start with that, because obviously if you want to solve a solution, solve a question, you have to have some kind of hypothetical situation for you. You have to have some assumptions. And after that, quantifying the sold, the QX is going to be 100 subtracted by 10X. So at this point, we can find the revenue, which is going to be price multiplied by quantity. So 5X times this guy is going to give me a quadratic equation. So as you can see over here, I do have 500X subtracted 50X to the power 2. A is negative 50, so I do have a curve that is going to open down. So obviously I do have the maximum point, and I would like to find that specific maximum. So at this point, I would like to convert it to the thing that I like, or we can some kind of do another thing rather than just converting to the vertex form. We already know a formula, right? We know that X is equals to negative B over 2A. So what is my B at this point? I do have 500 as my B itself. So negative B would be negative 500. What is my A? A is going to be 50. So 2 times 50 is going to 50 to be specific, is going to be negative 100, and negative 500 divided by negative 100 is going to give me 5. What does that mean? It means that if the answer would be the optimal number of price increases is 5 and the best price is going to be $25. What just happened? If you increase the number, if you increase some kind of your price, $5 by after some kind of increases by 5, you can find your maximum revenue, and that maximum or the best price is going to be at $25. You know that at $25 you are going to have the maximum revenue. Anything before that and after that is going to give you some loss, or no, you're not going to have the maximum revenue itself. That's how we use the mathematics in order to solve this kind of question. Let's talk about another part. Let's talk about the missile launching, or some kind of, we can say it as an object that is thrown in the air. Imagine that you have an object is thrown. When does it reach to a peak height? I would like to know that after how many seconds I would reach to this one, and what is that height exactly. And again, we are going to use the vertex form, right? I'm going to find any x-axis, and this one is going to give me the height or maximum height itself. And imagine, based on the physical laws, the h or some kind of the height is going to follow this one. Negative 16 t to the power 2 plus v0, or the speed at the beginning, times t plus h0, or is going to height at the beginning. So imagine the speed is 48 foot per second, and after that I do have the height is going to be 10 foot, the initial height. So if we do have this value, the only thing that we have to do negative b over 2a. So if we just solve that one, negative 48 divided by 2 by negative 16 is going to be 1.5 second. I know that after 1.5 second, or sorry, at what 1.5 second, I know I do have the maximum height as it's going to be 46 feet. So the ball reaches to its maximum height of 46 feet after just 1.5 seconds itself. Again, we use the vertex form. And another point, I do have another question. Imagine that I do have a question that says we do have a fixed amount of fencing and want to enclose the largest possible rectangular area. We need to find a maximum. Our best tool again is the vertex form. So how we can say that again? Why the vertex form? So I know for a fact that I do have right now, imagine that you have the based on this guy as a 40 units. So I do have the perimeter. The perimeter itself is 2 times length plus 2 times width. So 40 equals 2 times L plus 2 times X, which L is going to 20 minus X. Maybe some of you have a little bit doubt about it. So this is X, this is 20 minus X. If you add all of these things, it would be 40 units, right? So right now, I know for a fact that L, or the length, is going to, or I can say that my length is going to be 20 minus X, and X is going to be my width, or vice versa. Doesn't matter. No, it doesn't matter. I only consider one as variable, and another one is going to be dependent to that variable. It's going to 20 minus X. So we're talking about the area, right? So area would be length times the width itself. So I do have 20 minus X times X itself. It would be 20X subtracted by X to the power 2. So obviously we are talking about the quadratic equation, and again, since it's open down, I do have the maximum point. How I can find the maximum point? Again, negative b divided by 2a. If I negative b divided by 2a, if I do have that one, it means that I do have 10 units. What is that 10 units? It means that if I consider X as 10, and obviously my L is going to be 10, 10 or 100 square units is going to be my maximum value, or maximum some kind of area that I can get out of the system itself based on the 40 units. So we talked about the quadratic equation, but not in the standard in the normal form. We talked about the parabola, and we just try to look at the quadratic equation, or x to the power 2, from 3 different point of view. The very first point was the standard form, ax plus x to the power 2 plus bx plus c, and we some kind of learned that how we can use negative b over 2a in order to find a vertex. Another form is just the vertex form itself is going to be a times x minus h to the power 2 plus k. So at this point, by considering h and k, again we can find the minimum and maximum. And the last one was a times x minus r1 times x minus r2, and we learned how we can use the formula, which is negative b plus minus square root of b to the power 2 subtracted by 4ac divided by 2a, in order to find those roots. What are the roots? Roots means that what is the interaction, what is the interception of my function or my quadratic equation with the x-axis itself, while I know that if I put those x's inside the f of x, I'm going to have the 0 at the end. So thank you very much for guys to be here with me. And again, if you have any question, if you have any doubt about any part, just ask me, or some kind of comment down below. I'm trying my best in order to explain that to you. If you didn't understand it, again, I'm going to make another video out of it. But for one that we would call about the perfect, some kind of x minus a times x minus a, again, x minus a to the power 2. So perfect squares, we are going to make another video for you. So don't worry about it. Everything is going to be understandable on that time. But right now, just try to focus on the questions. Try to some kind of yourself, or so you can find them online in order to completely understand it. So without further ado, thank you very much, and my name is Mahmoud Kiasari. Have yourself a great day, night, whatever. See you around.